to do, and I think we're a pretty fun group of volunteers. Are there any other announcements before we get going? Okay. Before we start the talk by Dr. Suzanne Metlay, John Ensworth, who's one of our volunteers and who also runs the NASA Education Review Program, is here to give a brief science introduction.
Thank you very much. All right, so we're doing little 5 to 10 minute warm-up talks in front of many of the presenters going forward, and kind of going on the news of the day. So on June 1st, we had our third gravitational wave announcement made, and so thought that would be a good thing to cover this month. So let's jump right into it here. A little definition quickly. There is gravitational wave and there is gravity wave. Those are different things, but people get a little sloppy sometimes and use gravity wave. I may even slip and do it because I'm a meteorologist too, and so, I don't know, crosses over inside my brain. But a gravitational wave is a wave in space-time itself, created by gravity and predicted by Einstein's general relativity almost 100 years ago. So what do we do to see gravitational waves? See, I did it right there. We use something called an interferometer, really precise interferometer, similar to what proved there wasn't an ether back in the late 1800s. So this is a new kind of astronomy. This is one that doesn't use electromagnetic radiation or particles interacting electromagnetically at all. So it's an exciting new world. We had the TMA 300 turned on in 1999. That was turned off in 2004. It didn't find anything. GL 600 in Germany started in 2001, and I think it's going to be decommissioned pretty soon here. And it hasn't found anything definitive either. LIGO, I think it is. Is it pronounced LIGO or LIGO? Do you know?
LIGO.
LIGO? Okay, LIGO is part one of the experiment that did it. It ran from 2002 to 2015, and then they upgraded the instrument tremendously, improving its performance a lot, and we'll see that that worked. There are 11 more that I didn't mention, and 6 proposed out of that 11 that will be coming online over the next 10, 20 years, including ones proposed to be built in space. So, the advanced LIGO was a success. There are 2 observatories actually that make up this system, one in Louisiana, one in Washington. It's planned to be eventually 10 times more sensitive than the original LIGO experiment. It was turned on September 12th of 2015. It was at about roughly 4 times more sensitive at that point. They were calibrating things, seeing how stuff worked. 2 days later, they got a signal. Like, oh, is this fake? Did someone just feed some test signal in? Is this a practical joke? They didn't know, so they had to check everything out. The amount of motion in the mirror, the distance change between the mirrors at both ends, is about 1,000th the width of a proton. That is the equivalent of a hair, one of your hairs, motion of the Earth between here and the nearest star system, Alpha Centauri. That's really sensitive. This matched mathematical predictions of 2 infalling black holes, because if you can't see it with the telescope, you can play with it in a computer and see if you can see what it might look like. So that was really exciting. We did have hints looking at how the timings were changing and neutron stars going around each other. The gravitational waves existed, but it was sort of indirect. This was the signal. So, John, if you'll hit play for me. Hello, John. If you'll hit play. This is a computer animation simulation of what 2 black holes merging look like. Gravity itself warps space and time around them, so the light bends around them like a lens in space. It's a 3-dimensional warping of space and time. So you can see this weird optical effect going. They're getting closer. Here they come. Oh, maybe they're not going to do it this time. Oh, there they go. Okay.
Whoa.
And what's really exciting is that last moment where you saw all the picture shift a little bit. Let's go to the next. You can go ahead and hit play again. So we're looking at this little signal down at the bottom of the animation. It's covered by the animation bar for a moment. This little warble, as they go around each other, you see the two black holes are not the same. You can't expect them to be the same. And they're getting closer and closer. Things get more violent. My computer even got more violent. And then, boom, and out goes the merger moment. So, the very easy to remember name GW150914 occurred 14 September 2015. They waited months to announce this because they had to check everything. But you can see the Washington and Louisiana signals, and they superimpose them there, and they matched. They both got the same story, shifted by a little bit. So that meant they could get a rough idea of a big arc of the sky where these two did it. Then another one came along, 26 December of 2015, GW15126, and it has a really cool signal there too. So what made these two signals happen? The first one was a 0.2 second chirp, when the waves get really close together there, 0.2 seconds, you had 5 orbits of these black holes in 0.2 of a second. We can figure out by looking at the shape of the wave and the amplitude of the wave how far away that is, 1.4 billion light years away. And the two original black holes were about 35 and 30 times larger than our sun. So the precursor stars were even bigger to have gone through their whole lives, supernovae, left behind these big black hole cores, and then these merged. This released 3 times the amount of energy that our sun contains in that moment. That's really hard to imagine. That's just, E equals mc squared, mass and energy are equivalent. So that's just mind-boggling. The one that came in December, they were smaller, 14.2 to 7.5 masses, so it took a little longer for them to come together. Their chirp lasted a whole second. They got 27 orbits in that last 1 second, and released 1 solar mass worth of energy. Pretty staggering. And the latest news that just got announced on the beginning of June was the third signal, 170104, 3 billion light years away. 2 big ones again, like the first signal, 31 and 19 times the size of our sun in mass. And what's interesting about these is that they seem to have had a spin different than each other. If the 2 stars formed together and lived their lives together and did all their stuff together, they'd probably be spinning in the same direction, very similar North Pole point in space, but these didn't. They were very different. So they came probably in globular cluster, we're guessing. This is so far away we can't see the original source. And they met and had a little fatal attraction there. So using X-ray studies, you can see black holes that we knew of before, and these are way off scale. There's another one here that isn't strong enough out of the noise of the signal for us to say we really saw 2 black holes emerge, but there is a 4th kind of one in the data there. But these are big objects that became really bigger black holes after the merging. So this is raising all sorts of questions and creating jobs for future astronomers who may be sitting in this room here. The first one I've colored red, the second event I've colored green, the third one I've colored blue, so you don't have to memorize the numbers. The first one showed us that there are bigger black holes out there than we expected, as you saw on the chart. We didn't have any others like that. It also said if gravitons, which is the particle that would be like photons transmit light, gravitons transmit gravity, it gave us a limit to how much mass they could have if they have some mass. It's very, very, very tiny, but it's the first time we've had an indication of that from any real data in the universe. The second one came so quickly after the first, we are confident that this is a pretty common event in the universe. So we're going to get a lot of data as these additional instruments come online and become more precise and more. So that's exciting. That's job security for the gravitational wave guys. And that one black hole is spinning 20% faster than the maximum expected by general relativity. What on earth? So we've got some mystery science there, something we don't understand about how fast black holes can spin without weird physics kicking in. And the third one actually gave us a different constraint on how heavy gravitational waves can be. So why should they be different? Oh, I don't know. So we have a lot of interesting science yet to come out of that. People are also looking for bursts of light. With these violent events, the theory is you wouldn't get any light at all out of it. For the first merger, the Fermi gamma ray group said they saw something happen at the same moment or very close. European Space Agency's integral satellite didn't see anything, and then they found an error in the Fermi team's work. Second one was smaller, and nobody claimed to see anything. The third one, the Agile satellite, saw a glow on the arc that this could happen on. Other observatories saw something 24 hours later. Well, that shouldn't happen. So people aren't agreeing yet. And some of that is because when you only have 2 observatories, there's a big part of the sky where this could come from. So we need a third or more. And it's proposed that we'll build a third one in India called Indigo. This was approved in principle, February 2016. I don't know what that sounds like, but it sounds like nobody's writing a check yet. So it's just my guess. And finally, we might see some really interesting physics come out of this, because in the last instant when the black hole is a little shaking and then settles down just to be a black hole that it's going to be for a very long time, we might be able to figure out quantum effects happening in the event horizon of black holes and figure out some things about quantum theories of gravity by watching the ring down. We need a lot of these events and combine this data. We need big black holes merging with little ones and similar ones and spinning ones and magnetic ones, and we need lots of that data, and we'll get it over time. So any quick questions on gravitational waves? Yes?
What are gravity waves?
Gravity waves are, we see them here, when you have air going along and it's got a certain buoyancy and something kicks it, like a mountain range, it goes up, forms clouds maybe, and that clouds will release energy, it goes down, warms up again, but the buoyancy is just right, that goes back up and then down and up and down and up and down and up. So you get this buoyancy roller coaster in the atmosphere for parcels of air. Good.
Okay, so the air is moving up and down.
Yep.
Basically.
Yep. Playing a game with gravity and buoyancy. Yep. All right, any other questions? All right, thank you very much. I always bring one fan.
That's
It's
right.
just smart practice.
All right, let's see if I've got it going on. Can everyone hear me okay? Yes. All right, I'm going to end up yelling anyway. So if I get really loud and it's too loud, let me know. If I'm not loud enough, let me know. Just let me know. The other thing I want to do is make sure that, oh, what did I do? See, I'm trying to make sure I know how this works. There we go. There's a little bit of a laser pointer. All right, so I have no pockets. I didn't think about this. So I'm just going to hold stuff in my hands. We'll be good. So, nope, I have to hold them, but thank you. So, thank you everyone for coming out tonight. Obviously, I'm Suzanne, I'm your speaker tonight, and before we get settled with anything, anyone who's young or young at heart, if you want to stand up and get some wiggles out, get some jiggles, go ahead, do that. Let's take a minute to stand up, deep breath, wave arms, jiggle, wiggle, get all of, because I don't want to bore anybody, and thank you. And I want to make sure that you've got energy, you can go ahead and sit down again, that you've got energy to do some viewing tonight, because it should be a beautiful, clear night. We should hopefully see Jupiter. Does anybody know when is Saturn coming up?
Saturn will be up soon.
Okay.
Probably won't be in the telescope until about 10 o'clock now.
Okay, but if I blather, then I'll try not to keep anyone up past bedtime. The other thing I want to point out is, as John mentioned earlier and as Andrea mentioned, I've got some handouts as well as the Eclipse glasses. So on the front side, I give you some really important eye safety information. And on the back, I give you a map. Also, I give you some apps and websites. So definitely, if you're going to come up here to look at the Eclipse glasses, go ahead and grab a flyer. But really, the important thing is you need the eye safety, and you want to make a donation to LTO. So right by the back door, you don't have to move, stay right where you are, is a box with a big dollar sign on it. That's kind of obvious. But there's also a small donation box right here up front. It is such a pleasure to be back here in Berthoud. I just love LTO and the fact that this room, this entire building, it's all made with love by the people here. And so thank you, Berthoud community. Okay, now, does anybody have anything they want to talk about before we get into the talk? All right, then let's get to it. So, yeah, obviously, we're going to have a really fun day on Monday, August 21. If you have friends and family in Wyoming or Nebraska, now is a good time to bother them. If you don't, we live locally. You can make a day trip of it, and I'll get into some more details about that. But you certainly don't need to go get a hotel room and all that. However, if people want to pay you to stay at your place for a while, that's okay. So, what is going on? I'm going to need some young volunteers before we do anything. So, oh yes, Styles and Clarice and Zoe, yes, come on up, and you come up too. Basically, anybody who wants to be a volunteer, I need pairs of people. So you have to come in twos. So we have 4 volunteers right now. Do I have anybody else? Jorge, if I stare at you long enough, can I make you come up? All right, and is Stephanie around? We need one more person. Thank you. Do you want to come up? Me? Nope, in the back. Blue shirt? Yep. All right, thank you very much. All right, so I am going to need you in height pairs. So if you don't mind, Jorge, would you go toward the end? And you come toward me, Styles. Okay, so what you're going to do is whoever is taller is Earth, and whoever is smaller is the moon. So can you get into pairs and figure out, so it's going to be you two, and you two. So who's Earth, who's the moon? You're Earth. Okay. You are the moon. So here's what's going to happen. Earth, and by the way, I'm the sun, that's why I wore yellow. Okay. Earth is going to spin slowly. And so, you know what? Nope, not yet. I'm still giving directions. I need, what's your name? Lou. I need Lou and Styles to come over here because we're going to need some room. I'm going to need Zoe and Clarice to be right in front. Okay, so Earth, you spin slowly. Why? Because the moon has to go around you. So whoever's Earth, take one step this way, come toward this. If you're Earth, if you're the moon, stay right where you are. Okay, if you are the moon, You are going to keep your eyes on the Earth at all times. Earth, you can ignore the moon. You just do your slow spin, because that's what Earth does. It's really once every 24 hours, which is not very slow, but if you really go fast, you're going to make the poor moon like run rings around you, which actually could be fun. So I'm going to leave that up to you. But if you're the moon, you have to look at Earth at all times. Okay, so stay away from the table. Try not to trip on the people in the front. I'm going to stand over here because I'm the sun giving you my sunlight. And go, please model. So Earth, you spin. Moon, you move. You go around. Zoe, go around. You've got to go around. Make sure if you are the moon, you always keep your eyes on Earth. You have got it. Keep going. Is anyone getting dizzy yet? I haven't even put in tilt. Okay, stop. You guys want to do tilt? Yeah. All right, and you guys can do this too. Anybody who wants to stand up in place, let's make, oh, I'm the sun. Just tilt toward me. So what you want to do is put your hands up above your heads like this. So that's your North Pole. The top of your head is the North Pole. And now let's tilt 23.5 degrees, because that's Earth's tilt. And now go around in a circle. Oh, I got dizzy just doing that. Okay, and if you're the moon, okay, moons don't have a 23.5 degree tilt, but you look good doing it. So go around Earth while you're tilting. No, hands up, and tilt and go around. And it gets a little more challenging, doesn't it? All right, so that's not, you may stop now, thank you. That's not quite scientifically accurate, but that was fun, right? Thank you, guys. I could not do this without the superb volunteers of Little Thompson Observatory. I'm telling you. So, this is what's going on. We're going to have the moon going around Earth with the sun off to the side. We're going to have everybody's equator aligned. So everyone has an equator. Mine is larger than usual, which is why I'm a good sun. And most objects orbit relatively in the equatorial plane of a larger object. But relatively is the important part. It's not always exact. And so as the moon goes around Earth, and as the moon and the Earth go around the sun, it's only once in a while that everybody's equators all line up just right, and we get an eclipse. But it's particularly rare for us to get that when the track of that shadow that the moon casts on Earth happens to come right across the United States. And this truly is an all-American eclipse. It'll hit a little bit of Canada. Well, no, it won't really hit Canada at all. So it's going to start in the Pacific Ocean. It's going to hit part of Hawaii. Then it's going to come across the continental U.S., and I'll show you the map in just a minute. And then off the coast of South Carolina, in the Atlantic Ocean, it goes away. So really, we are the only country on Earth that will experience this eclipse this summer. And this is a good time to be an American. So totality, I have too many things. Totality is what we call that shadow. And I'm going to use this word a lot. It's really when you're in this deep part of the shadow that technically is called the umbra. Now, what word does umbra make you think of? Umbrella. That is exactly right, because when it was invented in Italy a few hundred years ago, it was a little shadow you could carry with you. That is what an umbrella is. They weren't designed for the rain, they were designed to shield you from the sun. The penumbra is close to the umbra. So anybody in the penumbra is going to get a partial eclipse. And then it's really important that those friends and family members have eye protection, because you don't want anyone ever looking directly at the sun. And if they're not going to get a full eclipse, then they can really hurt themselves if they're not careful. So let's look at this map. First off, is this gorgeous or what? That's made by Tyler Nordgren. He was actually selling these online for a while. And he donated some of this art to the National Park Service. And you can see that there are several national parks that go through this band of totality. But if you have family who live in other parts of the country, you can see that 90% is this range on either side of the totality band. This is 80%, 70%, and so on. So my family and I live in live in Longmont. This is Berthoud. Longmont is at something like 96% totality, not good enough. For you who live in the Berthoud area, you're at like 98 or 99% totality, not good enough. Get in the car and drive. The nice thing is that there is an organization called StarNet, and the Gordon and Betty Moore Foundation through StarNet donated 2 million eclipse glasses to public libraries all across the United States. So if you do have friends or family in Missouri or Kansas or wherever, you can tell them to go and get their eclipse glasses there. Or, of course, they can purchase them online. But I'll tell you, the companies that make these things are going insane. So better off to get them early and to get them through an eclipse glass. Because you know what? I got a really good deal on these because I bought them in bulk. But if you're just buying 1 or 2, you're better off going to a public library and getting them that way. And then handing them back to the library so that they have them for the next good event. So here in this area, I checked. I got a screenshot off the website. So here's Longmont. You can see that the library near Loveland, some near Greeley. I don't know why Fort Collins doesn't have a green one, but anybody who's got a green one, like Red Feather Lakes, that public library has eclipse glasses. You're going to buy them here and donate the proceeds to LTO, but if you do need extra glasses, go to the public library. Okay, so you have to be careful. My husband actually got a Facebook post from his older brother just a few days ago saying, "Can't I just wear dark sunglasses?" No, not if you want eyesight afterward. So you really have to be careful. These particular ones come from Rainbow Symphony, but American Paper Optics, Southernmost Optical, and TSE 17 have them also. I had a question earlier about welder's glass. It must be number 14 or darker. If it's just a number 6 welder's glass, that's not good enough. You've really got to go dark. When in doubt, go dark, because you don't want any damage to your eyes. And it hurts, right? Why should you hurt yourself for something that should be fun? So make sure that you are safe. If you do have a friend or family member who just, for whatever reason, didn't get the memo, they can always do this technique. Turn your back to the sun. Don't look at it. Hold out your fingers and everybody practice this. Hold out your fingers and make a grid. Or put your fingers together and then just pull them apart slightly. But that will be enough to make your own pinhole camera. You're doing it with your fingers. And you'll see the little crescents of the solar eclipse starting. So really, you don't need equipment. If you have, yes?
Camera, it's projecting down.
That's right. It's projecting onto a piece of paper or a wall or the ground. But yes, thank you very much for that reminder. Make sure your back is to the sun. Don't look at it with your face. It'll be plenty bright until it's not. And so go ahead and do that. If you do have a piece of paper, then obviously prick a little pinhole in it. Stiff paper is better. And same thing, look away from the sun and project that image on the ground, on the wall, on another piece of paper. That's what a sun spotter is. Has anybody used a sun spotter? Some of you have. And if you have not, have you ever made a pinhole camera out of a Pringles can or a milk carton? Really, orange juice can?
Or a big cardboard box.
Big cardboard box, yeah, all of that works. Anybody who has one of those Google VR, cardboard things, you can use that too. So anything that you can use will work. And one of the nice things about this handout is toward the bottom, right above the logos at the bottom. There's a link from Big Kid Science on how to make your own pinhole camera using a milk carton. So I want to make sure that you can do that and have fun on Eclipse Day. It would also help if I used the right doohickey. All right. You've gotten to where you're going to go. You're all set. You're watching the eclipse, and you've got your glasses safely on. But then it's going to get dark. It's really going to get dark. It's going to look like the clouds have moved in. Can you ever take off your glasses? Sure, of course. But only when you see Bailey's beads. Bailey in 1836 realized, oh my gosh, the craters of the moon are letting some sunlight through. But the whole idea is that the moon gets in the way of the sun. So if the moon is blocking the sun, then you're in shadow. You should be safe for a minute or two only to take off your glasses. So when you see the Bailey's beads, now remember, it's going to be bright. That might make your eyes water or hurt. Keep your glasses on. But when it gets really dark, you can take your glasses off and experience the eclipse that way. But you've got to put your glasses back on when you start seeing the Bailey's beads again. And you got to be quick because you don't want to hurt yourself. Any questions or comments or stories? Has anybody done this? So, okay, hey, you have done it. So tell us, what's it like to be in an eclipse? A solar eclipse.
Eerie. We went with Dr. Duncan.
Oh, hold on. Let me hand you the microphone. But, all right, well, I will narrate. You went with Dr. Doug Duncan of the University of Colorado at Boulder.
I think it was 2005.
2005, 2003.
Somewhere around there.
Okay.
It was in the middle of the Mediterranean.
In the middle of the Mediterranean. Awesome.
And it was very eerie.
Eerie.
It was dead calm.
Dead calm. Not even bugs?
No.
No
I
bug
I mean,
noises.
all I can think of is eerie and dead calm. And
You really see the corona.
yeah.
Oh, well, can you explain what is a corona?
Yeah, you really see during totality, the corona is 5 times bigger than the sun.
So it's the atmosphere of the sun.
Yeah, so it's much bigger than just the spot of the sun. It's really cool.
It's like and like the sun's like it's like it all dark.
Yeah.
Like you just see the moon.
You weren't born yet.
But he's absolutely right. You did well, Lou, because you were right. Yes, ma'am.
We were in Germany when the last eclipse happened, and what we noticed more than anything was the birds stopped singing. It was just utterly quiet and still.
That's remarkable. Oh, there's another story. Okay.
So this isn't a story. I got my question.
Sure.
When is the next event like this going to happen?
I did not look it up. Did anyone else look this up on Wikipedia?
July 2nd, 2019.
And where on Earth?
Right out in the middle of the Pacific Ocean.
Okay, so where's the next one in the United States, please? Somewhere around Texas. In what year?
2024.
2024. Okay. Okay. So this is why it's worth getting your eclipse glasses and holding on to them, because you will have them. Gordon.
Yeah, last one job in Europe, the northwest of England. You've been on camera, showed my kids on the back lawn, and as the other people said over there, amazing how bird life goes quiet.
That's incredible. Okay, so I'm reading off your phone. The next event in Texas will be in 2024. I'm sorry?
Where's the longest spot of totality?
I'll get there in just a minute. Okay, so let me get my microphone back on, and that means turning all of this off for a sec. Okay. So, there are going to be 5 phases to this eclipse. And here's the answer to your question of how long is it going to be. Really, all of this fuss for only 2.5 minutes at most. At most. You will have less, depending on where you are. So I just randomly picked a spot on the Wyoming-Nebraska border at centerline. I'll explain what that means in just a minute. But I wanted to give you a vague idea of what works here. An MT is mountain time. Of course, it is mountain daylight time. I don't know what happened there. Okay, so it's mountain daylight time. And notice it starts at about 10:25 in the morning, which means if you're going to be driving up to Nebraska, you want to get on the road early. There are going to be lots of other people on the road with you, so I'd say be on the road by 6 a.m. I see you've got a Carhenge t-shirt on, and my husband and I celebrated our wedding anniversary in Carhenge just a few weeks ago, and it was awesome. But they are planning on 10,000 people at least. And a lot of them are going to, get hotel rooms and stay overnight, but there's still going to be people like us clogging the roads. So plan on a picnic lunch, have snacks with you, make sure you bring water and sunscreen and all that, and find a favorite place and camp out. Okay, Carol and then Jean. Carol, did you? Oh, okay, right behind. Yep.
We come from Scottsbluff, Nebraska.
Oh, excellent.
So basically, we're just going to step up and do a bunch of hotels and RV parks and everything. They're already booked.
Yeah. Jean.
How long does the Bailey beads last?
Oh, the Bailey's beads are only like 20, 30 seconds. It's not long at all. Yep.
We have a copy of your slide deck on the...
Yeah, I will make this slideshow available.
Putting everything up on our YouTube channel. You can access that through the Star Kids website.
But yes, the slide deck, I'll make sure that you keep a copy and put it on the website as well. Thank you. So the important thing is be where you're going to be no later than 10 a.m. and then just have fun. The eclipse is actually going to look pretty boring. You're like, I don't see any difference. It's going to look, the sun is going to look like a cookie with a bite taken out of it. And the bite's just going to get bigger and bigger, and this is going to be like the slowest hour and 20 minutes of your life. So go have video games or something else to do. Go to some fun astronomy, citizen science sites. The Zooniverse, Zooniverse.com, has a lot of good citizen science stuff for you guys to do while you're waiting. And you'll notice eventually that it's just getting darker. It's like the clouds have moved in, but there are going to be no clouds if we're lucky. And it's just going to get darker and darker until, notice, at 1:45 noon, not at noon, but at 11:45 a.m. or thereabouts, that's when you're going to start to get really dark, and you're going to start to see your Bailey's beads and what's called the diamond ring effect, because after a while, all that sunlight's only going to be available to see through one crater on the moon. And so all that sunlight concentrated in one spot. And then it's going to go away, and you're going to be in shadow, and yes, it's going to be dark. The sky will be black. You may see stars. I don't think we're going to see an aurora because we're so far south, but if we have a particularly active sun, you might be able to see some prominences or flares, especially if you're using a sunspotter or that pinhole projection technique. So lots of interesting things can happen. And then, as I said, it's going to be at most 2.5 minutes. And then it's going to end. You're going to see those Bailey's beads again, and it's time to put your glasses back on. Now, as people have said, not only does it get really quiet, but all sorts of things. You know, if you have a dog with you, your dog's going to behave a little weird because nobody explained to your dog that an eclipse is going on. So really, have your animal friends with you and just see how they respond while, as I said, you're waiting. But boy, look up. Right? It's only going to last a minute or two, and this is an important event in your life because this is a bucket list thing, right? You want to say you've done it. And if you're young, you want to know what to plan for the next time you get this opportunity. And think of things you want to do. So keep looking up. Do not look at your cell phone. Do not wash out your dark adapted eye by looking at a bright white screen, because I know a lot of us want to do that. If you are going to have your cell phone out, please put a red filter on it. Astronomy apps always have a red setting. That's okay, but don't make it unpleasant for other people by washing out their view. And then, of course, then it's over, and everybody's going to want to get in their car and drive away. Don't. Stay where you are. As I said, bring a picnic lunch, and let all the idiots get off the road first. John.
You probably won't be able to tweet or anything because the cell phone tower will be totally overloaded. So don't worry about your phone.
Yeah, it's fine for 2.5 minutes to turn off your Facebook feed. It's really okay.
Do you have suggestions on how an amateur with crude digital photographic devices take pictures of this?
You know, the question is, do I know how an amateur can take pictures of it? And I honestly would say, leave it to the professionals. Just soak in the experience. Let other people mess with their tech. Because the experience is what it's all about, right? The journey. You've traveled to your location. Hopefully you're with friends or family, or even if you're just surrounded by total strangers. Enjoy the social aspect. And don't worry, because NASA and others are going to have gorgeous pictures that you can steal. If you do want to, mess with your camera, that's fine. And I will let other people who are photographers, especially digital photographers, answer your question. But my real recommendation is don't.
We can talk about it afterwards if you want. You're going to need specialized filters for your camera. If you have a DSLR, you have a point and shoot camera. There's probably not much out there that's going to cover it for you. Not using the correct filter, the correct size filter, will burn your camera. This is another sign.
Yeah, Mark made an excellent point. If you could not hear him, he said, the eclipse will burn out the optics of your camera if you don't have a filter on your camera. So we're so worried about protecting our own eyes that we forget, and then we look in the camera. Ouch! Don't do that. And yeah, don't damage your nice, expensive digital camera by blowing out its brain. So.
Same thing with your cell phone camera.
Question, for those of us that are not going to travel with all the other crazy people out there, what can we expect here?
Yeah, I will get to that in just a sec. I'm not actually aware that anyone local is doing anything because, again, we don't need to. So let me advance to that really good question.
We'd be happy to help you here, but I don't think anyone's
Yeah, nobody's going to be here at LTO. This is from the U.S. Department of Transportation Federal Highway Administration website. This actually came out last year as a warning that this is the first act of nature that is not a disaster. That's going to bring about 200 million people out on the roads. Yeah. I mean, look at this. Nearly 2/3 of the United States population. Okay, now think about that. That means we have 300 million people in this country, and 200 million are going to be trying to get to center line.
Yeah, but most of them are back east.
That's true. But what it does mean is, yeah, be careful. And so we do have the advantage of living very close. And so this is what I want to get into, just some really sensible tips and tricks of what to expect. I would say expect crowds, and here's what you want to do. This blue line that runs from Casper, Wyoming to Alliance, Nebraska, and of course beyond, that's what we call center line. And notice that on I-25, Glendo, Wyoming is right on that center line. So is Casper. So is Alliance in Nebraska. So yeah, that's where all the crowds are going to be. So guess what you're going to do, because you're really smart.
Leave very early.
You're going to leave very early, and you're going to go past center line. Go to these northern locations, because there are not a whole lot of people who live in northern Wyoming and this is South Dakota, here's Nebraska. Go past center line, you will get 2 minutes and 10 seconds of totality. And in exchange for the 15 seconds, if you just drive 15 or 20 minutes past, you will get far fewer crowds. And all you have to do is pull into a Target parking lot or something and you'll be okay. You don't need any special equipment other than the eye safety. So I would recommend that unless you have friends and family and you've already arranged to be with people at Centerline, anywhere in this gray band is okay. You don't want to be so close to the gray band that you're outside of it. So use some common sense there. And this is why on the back of this handout, I give you this same map and some apps to look at so you know exactly where you are. But go past or be a little further south here, but because we have more population density, there are a lot of people who are going to come through Wheatland. There are not that many people who are going to go past Douglas. So I would say, if you don't mind, just drive past Douglas and then find some place up here in this more northern part of the band. Okay, you've got a question.
So is the length of totality the same if you're anywhere in the gray?
No, that's a good question. Is the length of totality the same? No. The further away you are from the blue center line, the less time you have. However, it's still going to be like 1.5 minutes up here and, around Torrington, Wyoming and Scottsbluff. You're still going to get a good 1.5 minutes. And as I said, that additional 30 seconds or 15 seconds, just save yourself some hassle. Now, you do live in Scottsbluff. It's going to be insane where you are, right?
Yes.
Yeah. So that's why I'm saying get up early and drive past. If you get to Herringford, you'll be fine. Okay, yep. Mike, what is your question or comment?
Just two things. First of all, please keep in mind that as long as you can see the sun, you can see the eclipse. All you need is a wide open space. However, you want to be careful if you park in a commercial parking lot and their lights are photosensitive, they will kick in and you're going to have a lead balloon of a
Oh, that's a good point. Go rural. If you can, go rural.
All you need to do is find some quiet highway where you can safely pull off the road and not block traffic, and you'll be okay. The other thing I want to point out is that this is derived from, she'll talk about this in a little bit, there's an iOS app, Totality.
Yeah, I'm going to get there.
Which is free and which is a heck of a lot of fun to explore, so I recommend it.
Thank you. Yes, did you have a comment? No, right behind you. Nope. Okay, anyone else? All right, so let's move ahead. So, is there an app for that? Why, yes, there is. Yes?
I had one.
Oh, sure.
And that was that
Hold on, let me undo the microphone.
no. It's at 11:45 here, but on both coasts it's going to be a lot earlier later.
Well, yes, that's true. I gave you times for our local area. If you have friends who live in South Carolina, yes, the times are different. If you have friends in Oregon, the times are different. But I figure you're just interested in what our local experience is. But yes, the times will vary. So this is why you do want to check your app. And so I have 3 that I'm going to tell you about. The one that Mike mentioned, this is definitely my favorite. This is from Jeff Bennett at Big Kid Science. And he and Doug Duncan both were at the University of Colorado at Boulder. Doug Duncan is still there, but Jeff Bennett now does this kind of stuff. And he writes children's books as well as adult books about astronomy topics. So I really like this app. It is totally free. It's really easy to use. And all you have to do is plug in some information or just let it access your location from your phone, and it does the rest of the work.
If anybody wants to see it, I'll be glad to show you how it works after the talk is over.
Thank you, Mike. The other app that I recommend, I really like these guys. These are for the more technical of you, right? If you just want point and shoot, but if you're the kind of person who fiddles with the details on your own cameras, you might enjoy eclipse2017.org. First off, their website is wonderful. And that's actually where I got the map that I just showed you, was from this website. And these are just screenshots of what to do. Notice that they will tell you what happens if you're in totality, but what happens if you're not. If you have a friend who's living in Florida and wants to be part of the experience, but they can't because they live in Florida, you can tell them, well, at least you'll be able to see this much. So and it says the eclipse is not total if you live in New York or Florida, but it is total if you're lucky enough to be just north of where we are right now. So this eclipse2017.org website and app, also free, really good. And especially if you're into latitude and longitude and all that techie stuff. And I love maps, so I always have fun with that. This would be my go-to website. And I have this on my phone as well, so I'm happy to show you how it works. And then, of course, NASA was not going to get left behind. So NASA has their Eclipse 2017 web application and desktop for, if you want to impress your colleagues at work. This is a nice one because the eye candy is big and beautiful, and it's not on a phone, it's on a monitor. So I would absolutely go for these NASA ones as well. And what happens if you can't go anywhere? Well, if you have a smartphone, if you have a computer that can handle live streaming, it's all going to be live. And especially, what happens if you do all that driving and, oh my gosh, a cloud got in the way? Then yes, you can go to YouTube or NASA TV or Ustream or NASA Edge. Any of these internet channels, there are others. My own work, we use Ustream a lot. So I can tell you that these are good channels. I do have the NASA TV app on my phone. It is free. All of these things are free. YouTube is free. And there will be so many people who are live streaming it that if for some reason your life just doesn't accommodate you leaving the house, you can still participate, and you should, right? Don't miss this. Okay, so let's finally get into some science. Does anyone have questions before we do that? Yeah, John.
This is a model of traffic for Google, on Google Maps, so you can see what expected traffic is. I can bring that up now or later.
Oh no, do it right now. That'd be fantastic. So while John is doing that, he's right. You want to also have cotrip.org. That's the Colorado Department of Transportation letting you know about heavy traffic slowdowns or road closures and that kind of stuff. And obviously, check Google Maps or anything else that you use. Your GPS will not know that you have 2,000 people in front of you. So just be aware that your GPS might not be the best tech for you to pay attention to right now. Okay, so John, do you want to talk about this, or should I?
Go ahead. I'm seeing it kind of live too.
Okay, thanks. So again, we've got the eclipse track, and I'm pretty sure that red means really heavy traffic and slowdowns are expected. Yellow is, be careful. But what do the green indicate? Can you tell me, John, what is the green supposed to represent?
Well, they're expected not to be bad.
So not too bad. And so here we are. Okay, I don't want to go any further than, here's Casper. And did I just go right past Alliance? It should be right there. So here's Casper. Alliance should be right here. Yep, there we go. So it doesn't look too bad right now. Of course, as we get closer and closer and people get clued in, it will glom up.
So does anybody know what's missing from that map?
Anything outside the path.
Yes.
All that red on I-25,
Yes.
Yep, here's I-25, and yeah, you better believe I-25 is going to be clogged. So yeah, just plan carefully. Yes, sir.
What about like the day before, if you want to go get, find a camp spot or just...
That's right.
Is it still, does everybody have that night? Drive off of the Grand Dickens somewhere a little bit north of the line.
Yeah, some people have ranches and other private properties along the route, and they have been selling campground sites for 2 years now. So yes, you can go camping, but only if you know where to go. So yes, you can go ahead of time. A lot of people are planning that, but a lot of the obvious places to go, like RV campsites, are full. Yeah. What's your question?
I was just wondering, do you think the traffic is going to be as heavy coming back after the eclipse?
Well, yeah, because just like when a movie ends, everybody tries to get up and leave all at once. So yes, everyone's going to say, oh, the eclipse is over. And of course, they're going to forget the fact that we still have the end part of the eclipse, right? So I would say let everybody else clear out first. Enjoy the rest of the eclipse. Hang out with your friends. That's when you can pull out Facebook and Twitter and be on social media. Or just call friends and family and go, did you see that? And yeah, let everybody else clear out. The traffic will be heavy immediately afterward. John?
Small towns, grocery stores will get picked over, gas stations, and they run out of gas. So go in with a full tank and bring some. I'm thinking that it's going to be a 3-day weekend for a lot of people.
Yeah, a lot of people are going to places like Carhenge on Friday. So at least the traffic on the way there is probably not going to be that bad because you have so many people who are already in position, but on the way out it's going to be very heavy.
Just 25 more.
Okay, all right, so let's actually get to some science because this is my favorite part. So, can anybody tell me what must the phase of the moon be for us to experience a solar eclipse? The new moon, sometimes called the no moon. And can you tell me why? Where is all the sunlight going to be?
On the other side of the moon.
That's right. We're here on Earth. For us, it's just before noon in our part of the country. All that sunlight is going to be hitting the moon right on the side we cannot see. So we're going to see, this get darker and darker and darker. But then when the moon is right in front of the sun, we're not going to be able to see the moon either because it's going to be fairly black, right? When it gets right in front of the sun. It's like if I stood in front of the projector lamp, there'd be this really bright, intense spot in front of my head, but you would just see my face kind of in shadow. So what you want to do is be aware that, the sun is always half illuminated. The moon is half illuminated by sunlight at all times, regardless of phase. What we call a moon phase is just how much of that sunlit part of the moon can we see from our perspective on Earth. And notice is that when we get more and more and more sunlight, that sunlight reflected off the moon does not make its own light. It only reflects light. And during the new moon, sometimes you can see the moon. That's because of light reflected from Earth. And what did Galileo call it? Does anybody know? Earth shine, which I think is just gorgeous. Earth shine is light from Earth reflecting off the moon back to our eyes here on Earth. It's a lovely concept. So sometimes the moon is lit up by Earth, but most of the time it's lit up by the sun. And as we get these what are called waxing phases, you get, oh, I'm going in the wrong direction, aren't I? Waxing phases, you get more and more and more illumination. Notice this is all on the right-hand side from your point of view. So if it's lit up on the right, you know you're going to get more of that illuminated side of the moon facing you until we get the full face of the moon lit up. And this is why sometimes at night you can see a lunar eclipse. It must be in a full moon phase, but same thing. The equator of the sun and the equator of the moon and the equator of Earth have to be all lined up to get a lunar eclipse. We're talking about a solar eclipse. This is a lunar eclipse. And what color does the moon turn during a lunar eclipse? That's right, that gorgeous orangey red, because of refraction of sunlight through Earth's atmosphere. So if you get less and less and less light, then it's waning. The third quarter is sometimes called the last quarter. So the way I remember it is last lit left. If the last quarter moon is lit on the left side, you've got your waning phases. So that's how I remember. I look for right hand or left hand, where is it lit up, and then I can figure out where I am. And I actually teach science teachers, that's my day job, and I'm teaching the science teachers, some of whom are older than I am, and that's the mnemonic I use with them, and by golly, it's on their tests, and that's how they remember it. Okay, why don't we get an eclipse every month? Remember I said earlier that things aren't always aligned? You know, that's the joy to me of natural objects. We all have individual diversity. None of us look alike. No two snowflakes look alike. And no two planetary objects are going to be lined up with each other. That's just not the way natural objects work. So if you want to make sure that everything is lined up, great, but it's going to take you a while. So here's the thing. Earth's tilt with respect to the sun's equator is 23.5 degrees. And that's what I did earlier when I made you put your hands above your head and do the funny tilt. But it turns out that the moon has a tilt too. And we kind of didn't realize that for a really long time. But the moon is tilted a little more than 5 degrees from that ecliptic plane, that equatorial plane of the sun. And that's why it's really hard to get in eclipse position. Because it's not just that Earth is tilted, the moon is tilted. And so the moon, as it goes around Earth, isn't really lined up with us. And then we've got that whole thing of the moon always keeps one face toward Earth, but the Earth couldn't care itself as it rotates how it's aligned. So you've got to get everybody doing the same thing at the same time, and that's challenging. Has anyone heard about an annular eclipse? All right. And that is when you get an annulus, a ring around. And it's like, wait a minute, it's the same moon. How come on August 21, we're going to get almost complete coverage of the sun by the moon, but there are some days when we don't? It's because the moon's orbit isn't a perfect circle. And for that matter, Earth's orbit around the sun is not a perfect circle. There are almost no perfect circles. And this is what drove people like Copernicus bonkers, because they were trying to do all this work to prove perfect circles. This is what the ancient Greeks always talked about. The Greeks were right about lots of things, but not this. No perfect circles. This is not a perfect universe. I like my universes imperfect myself. So when you have the moon going around the sun, sometimes it's closer, and when it's closer to Earth, here's Earth in the center. And so we call that point, when the moon is closest to Earth, perigee. If we were talking about Earth going around the sun, we'd call that perihelion. And does anybody know when Earth is closest to the sun? It is, in fact, it's early January. So when you're really cold and bundled up, that's when we are physically closer to the sun than any other time during the year. And in fact, it's only on 4th of July weekend that Earth is at aphelion, the point opposite the sun. So when you're sweltering on that wonderful 4th of July barbecue or party that you're going to go to, that's when we are furthest away from the sun. If we're talking about the moon's orbit, it's furthest from the Earth at apogee. So ap means opposite. So when you're opposite that nearest point, you're at the opposite point, so apogee. And it means that sometimes you're going to hear on the news things like supermoon, and they're going to get all excited. Yeah, it's not really anything. Supermoons do not cause earthquakes. If there was going to be an earthquake in a particular location, it's going to happen anyway because of things going on with Earth, like plate tectonics or geologic hotspots. And if there's a supermoon, then you get to add on a teeny little factor for the additional gravitational pull of the moon. But man, it's not even enough to pull water up all that much. It's not going to make the ground go up that much. The ground does respond to the gravitational pull of the moon, don't get me wrong, but not enough to cause an earthquake. It's just going to make an already existing earthquake just that teeny little bit bigger. Well, so then what happens when you have a small one? And I loved this one. The guy who made this said, weenie moon? Heck, I don't know. We don't really have a name for when our view of the moon is at that apogee point, but it's just a little bit smaller, and that means we're going to have a little bit smaller coverage, and you get an annular eclipse. You don't have to worry about that in August. We're going to get a nice big full solar eclipse with real totality. Any questions? We're almost done. Why isn't the eclipse right at noon? Isn't this supposed to be when the sun is at its highest point? Sure, that's called zenith. And in your textbooks and ideal situations, your zenith is directly overhead. But you know what? We're back to that imperfect universe. And in this real world in which we live, the sun will get as high as it possibly can in the sky, but that may not be directly overhead. That may be just kind of sort of overhead. I mean, think about where you're sitting right now. There's the spot on the ceiling right above your head, and then there's where the projector is, right? And if you can see where the projector is, pretend that that's the sun. That's as high up as it can go, but that may not be right over your head. So, it depends on the season. Because, of course, we're about to, in a few days, celebrate summer solstice. And that is when the sun is as high up in the sky as it's ever going to get all year. But that's still not going to be directly up over your head. It's just going to be as high up as it can go, which is pretty high, which is why we get the longest day, because we have the sun is going to be visible to us during daytime hours. That is what daytime means, when you can see the sun, for the longest period of time. It's also going to be as far north in our sky as we're going to get all year. So actually, the sun is not going to rise in the east. On summer solstice next week, it's going to rise as far to the northeast as it ever gets. And then it's going to get as high up as it can go, which may not be all that high up, depending on where people live. And then it's going to set north of west. You'll only get the sun rising and setting directly in the east or directly in the west during equinox. And then during winter solstice, not only is everything as far south as you can go, because it's the south pole of Earth that's facing toward the sun, but you get the shortest day. You're just not going to have the sun up for very long. So there won't be time during winter solstice for things to get warm, which is why winter's cold. It's just the absence of heat from the sun. Any questions about that? Because that's a little weird. Yeah?
You skipped over the solar noon versus...
Oh, thank you. Actually, I was getting there. I just wanted to make sure I got seasons okay. So yeah, solar noon is when the sun is at its zenith, its highest point. But that's very different from what's on our watches, what's on our smartphones, because we as technological human beings have decoupled from the natural world. And that's not necessarily a bad thing. I mean, really, there are lots of time systems, especially used by satellites and other forms of technology, where we have to factor in things like Einstein's theories of relativity that John was talking about earlier with the gravitational waves. We have to really pay attention to how space-time changes as you have something like a satellite moving through space-time in its orbit around Earth. Well, the moon, dimples space-time as it goes around Earth. Earth dimples space-time as we go around the sun. And depending on what sort of need you have in your timekeeping, you don't want to rely on things like Earth and where the sun is from our apparent look, our view of things. Sometimes you want something a little more precise, like the ticking of electrons in a cesium atom, which is what an atomic clock uses. There are some modern clocks being built in Boulder where they're even more precise because they're talking about ultraviolet wavelength variations and things. So depending on what you're doing, you may need a different clock. Solar clocks, where is the sun? Oh, I think it's overhead. That worked really well for our ancestors. Doesn't work so well for us. We want our trains, our light rail, to run on time. Mike?
There is one other effect you're not mentioning, which is probably big enough to swamp all of this.
Yeah, which I forgot. What is it?
Time zones.
Well, that's the solar noons.
Yeah, solar noon is decoupled from the time on your watch because everyone in a 500 miles in either direction has the same time, but the sun is lower in the sky for one person while it's higher in the sky for another.
That's true, and that's why your times may vary, because even though Alliance, Nebraska is still in mountain time, you're right, you will experience a slightly different time than someone in Torrington, Wyoming. That is correct. However, again, it's a matter of what you want to do. We do live by our smartphones, don't we? And our watches. So I would go with what's on your tech, but just be aware that this is different from what's occurring naturally. And it is fascinating. Timekeeping is amazing. And I think a few years ago I actually gave a timekeeping talk. And I'm happy to dredge that out again, but we have so many other fun things to talk about. I'll talk to you about timekeeping later. But Mike is absolutely right. Your time is going to be different than the time of the person who lives down the street, because you live just that much further over. Yes, sir?
Question, isn't it unique for the Earth and the Sun and the Moon, and that it's exactly the right distance away to be the right size to give us a real eclipse?
Yes. So hopefully everyone heard. Isn't this a really unique event to have a solar eclipse where everything is just the right size and just the right distance away? Yes, and I read a science fiction story many years ago. So many, I think I was Styles' age, so I can't remember who wrote it. But it was basically that solar eclipses on Earth are a big tourist destination for aliens. Because they don't get this on their world. So...
Any other planets in our solar system have
Other moons of other worlds in our solar system do have eclipses, but not like this. You don't get full coverage because the moon is usually too small. Most moons of other objects just don't have the same coverage. We really are unique in our solar system. And this is a unique period in Earth's history because earlier, when Earth and Moon were younger, they were closer to each other than they are now. And a few 100 million years from now, they're going to be further away. We're only going to get an annular eclipse. We'll never get full coverage. So enjoy this moment in time and space. This really is a unique opportunity, not just for your lifetime, but for the lifetime of this planet. So go and enjoy it. You're so lucky. Okay, so one other thing. This is my penultimate slide. One other thing, and that is, while you've got astronomy on the brain, the Perseid meteor shower is coming. And of course, the lovely thing about meteor showers is just because they peak over a few days, that's not when they start. This is going to start in early August, right around August 1st, and it's going to keep going through the end of August. So you're going to see most of the Perseid meteors between August 11 through 13. But a couple weeks before, a couple weeks out, you're still going to see stuff. So the best time for those of you who are night owls is to go out at about 3 or 4 in the morning. I know, most of you are asleep. But for those of you who are up, here's Polaris. So you know you're looking north. And just look a little bit east of that. If you can't do it at 3 in the morning, 10 or 11 p.m. is fine too. It does have to be dark. And of course, right around solstice, it doesn't get dark, I mean really dark, until like 9:30 or 10 anyway. This is going to be in August, so by 9 p.m. it should be pretty dark. And if you see any streaks or flashes, it's probably a Perseid meteor shower. Now, there are meteors that you can see all through the year. They're not always tied to showers. But these are the best times. And of course, this is nice because a nice warm August night, and you're out with your friends and family, and maybe you've got a campfire or one of those pit stoves or something. That's a nice way. Again, make sure your back is to the source of illumination. Let your eyes adapt to the dark, and just go and enjoy the sky show, if you're awake to do that.
So this is the warm-up act?
That's right. This is the warm-up. So there are lots of things always to enjoy at night, not just during the day. Now, I know it's teeny weeny print because I looked at a lot of sources. So I always give references, and so when you look at the slide deck on your own, if you want to know where something like one of the images came from, you can just look in here. And I thank you very much for this wonderful opportunity to chat with you today. Make sure you help out LTO. Help yourself by getting some eclipse glasses. Of course, these are yours, and they do not go bad. Do not dispose of them after the eclipse. I've seen people put these in the garbage. It's like, no, go to Texas 5 years from now, you're going to want one of these. So keep it forever. Just keep it in the glove box of your car. It'll be fine. John.
One more survival technique for seeing the eclipse I made. If you go back to the web, so look up from, if you
go ahead and do it.
Yeah, go to Weather Underground.
Oh yeah, Weather Underground is a wonderful site. It'll tell you what sort of weather to expect. Now, of course, nobody's a miracle worker with weather, right? So even the best website may be off. There may still be a little cloud right over you, but generally speaking, 3 or 4 days out, you'll get a good idea of what the weather is going to be. You could go a week out, but that's, things may change.
And what's nice about it is if you go into the graphical mode for a forecast, you'll be able to see clouds for any city that you want. Cloud cover out in about a week. I would trust it a day or two out. So let's go for Thursday. Under the 10-day weather forecast, click on graph. It's thinking about it.
Okay, so while the website is thinking about it, I want to give a pitch. For those of you who did stay, it is, we're sort of at twilight right now. So are you guys going to open up the scopes tonight?
The dome on the 24th is open. The skies are clear, the sun, the clouds are thinning out, they're not perfect. You should still be able to see Jupiter through the thin clouds. Saturn will be up, visible in a half an hour. High heaven.
Okay, so anyone who wants to stick around and do that, obviously, you are totally welcome to stay. I'm going to stay and answer questions for a few minutes. So if you're trying to kill time, you can kill it with me. And, all right, thank you. All right, thank you, John. Thank you, everybody.